All right, let's look at the volume of a solid. All right, so let's say we want to find the volume of a solid below the surface defined by z equals f of x comma y. So it's basically the graph of the function of two variables. And over the region in xy plane R. All right, so let's set up the integral. All right, so this is just like the area under the curve. This is going to be the volume under the surface. All right, so it's going to be a double integral. So we want to integrate. All right, so we want to integrate over this region in xy plane, so R. And then the integrand is just going to be the function for the surface. So f of x comma y, and with respect to x, and with respect to y. Right? Depending on the situation, you can do either one first. You can do a integral with respect to y first if that's more appropriate. All right. So let's look at a simple example here. Alright, so f of x comma y is given to be y over 1 plus x squared. Right, and the region R is bounded by y equals 0, which is the x-axis, and the curve y equals square root of x, which is drawn here, and x equals 3 is a vertical line. Alright, so let's set up an integral. Alright, so the volume V is going to be, right, then let's see, which way should we do? Alright, so the function is y over 1 plus x squared. Alright, so I'm going to try to do with respect to y first, and then after that I'm going to do it with respect to x. Alright. So what you want to do is to cover this entire region R, I'm going to first fix x, which is the second one. So I'm going to fix x here, right? Then to cover this, we know that we have to go from here, which is y equals 0. So I'm going to put y equals 0. So we usually put 0 here. So it's a y equals 0. And then you have to go all the way to until you hit this curve, which is y equals square root of x. So it goes from 0 to square root of x. All right, once you've done that, so we have to know where x goes. All right, so x goes from 0. So you start from here, and you keep on covering, x value as x value increases, and then all the way to the last one is obviously at x equals 3. So it looks like it's going to start from 0 and ends at 3. So we're going to put the 0 here and then 3 there. All right, so let's evaluate this. All right, so first I'm going to leave outside integral untouched. All right. All right, then here I can probably kick something out. So it's going to be there's a 1 over 1 plus x squared. This has nothing to do with x. Sorry, nothing to do with y. So we can kick this guy out of the inner integral. All right, so we can just put it 1 over 1 plus x squared. Right? Then we have an integral here. So antiderivative y with respect to y is a y squared over 2, right? Then we are going from, so y is going from 0 to square root of x. And then we still have to do with respect to x. All right? Then if you plug in, so you're going to have, if you plug in here, you're going to get this. So I'm going to put the 0 and 3, and there's 1 plus x squared on the bottom. Alright, so if you plug in square root of x, then you have to square that. So it's going to be x over 2. Alright, so I'm going to put over 2. So maybe I'll put x over 2 right there. Alright, and if you plug in y equals 0, it's 0. So I'm not going to write that. So minus 0. Alright, then we have dx. Alright. So then, if you remember, if you have an integral g prime of x over g of x, then antiderivative is just a natural log of absolute value of the denominator, g of x, plus some constant c. All right, we can create this fairly easily. All right, so here, first I'm going to pull 1/2 outside. All right, so we're going to put 1/2 outside. Then we have an integral from 0 to 3. Then you have an x over 1 plus x squared dx. All right, so what we want to do is we want to see this guy as g of x, and its derivative happens to be 2x. Right, and I have x, I don't have 2, but we can put 2. So what I'm going to do is I'm going to multiply the top by 2 and then multiply the bottom by 2. Right, that way we don't change anything. Right, so what you get is going to be, so it's there's an extra 2 on the bottom, so it becomes a 1/4. Right, and antiderivative of that is natural log of absolute value of 1 plus x squared. You don't really need absolute value because this guy is never negative. And then we're going from 0 to 3. All right, so we're almost there. All right, so you have 1/4. All right, if you plug in 3, you get natural log of let's see, so 1 plus 3 squared would be 10. So it's a natural log of 10 minus, if you plug in 0, a natural log of 1. I can put natural log of 1, but natural log of 1 is 0, so it's minus 0. So I'm going to actually not even write that. So we get that. All right, so it's a natural log of 10 over 4 is the volume of the solid under the surface, the given surface here, over this region R. All right, that's it. I hope that this was clear.